Hi class, just going to come in here and take up some of the questions from lesson 6 for you. We're going to do a full actual lesson on this in 6B, but this is just a take up of lesson 6A that you should have done by yourself. So if you notice here, you have product of power. So if you have 2 to the power of 10 to the power of 2 multiplied by 10 to the power of 3, we're just going to write it out in its product form, which basically is saying we have 10 times 10, which is 10 to the power of 2. And then multiplied by 10 to the power of 3, which is 10 times 10 times 10, right? And if you take that all together, you have 10 times 10 times 10 times 10 times 10. And if you count all the 10s, you're left with 5, right? So we're going to try doing the same thing for 10 to the power of 4. So I'm just going to go in here and I'm going to write 10 times 10 times 10 times 10, which is 10 to the power of 4. Everything multiplied by 10 to the power of 2, which is another 10 times 10. And if I add all those 10s together, I have 1, 2, 3, 4, 5, 6. So I have 10 to the power of 6 here, right? Same thing with the 5. 5 to the power of 3 is 5 times 5 times 5, multiplied by 5 times 5 times 5 times 5 times 5 times 5, right? 5, 6 times. So then I have 5 times 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 5. And if I add those together, I have 5 to the power of 9. 2 times 2 times 2 times 2 times 2, which is 2 to the power of 5, multiplied by 2. It is going to give me 2 to the power of 6. Right, and then I have negative 3, I'm just going to put this in brackets, times negative 3 times negative 3, which is negative 3 to the power of 3, multiplied by negative 3 times negative 3 times negative 3 times negative 3, right? Times, so that's 4 times, right? So I'm left with 1, 2, 3, 4, 5, 6, 7, right? 7 negative 3's, so it's negative 3 to the power of 7, right? So if you look at these, you'll notice some patterns that you see is that, you know, if you're looking at this, you can say that you are adding the exponents together, right? Because if you think about it, you have, 10 to the power of 2, so you have 2 10s, and then you have 3 10s, so then you're adding those exponents together. So a rule that you could state for multiplying two powers of the same number with the same base, right? So the same base is that you could say, okay, if we have the same base, when multiplying to when multiplying numbers, right? So the same base means that you have 10 to the power of 6 and then 10 to the power of 7, right? You can add the fraction. Oh, sorry, the exponent. So an example of this could be, say I have 10 to the power of 7 multiplied by 10 to the power of 8. I can just add the fraction, the two exponents, and say, okay, 10, 7 plus 8 will give me 10 to the power of 15. And it would be, if I had written everything out, would have given me the same amount. You need to be careful. 1, 10 to the power of 7 times 10 to the power of 8 is not the same as saying 10 to the power of 7 plus 10 to the power of 8. They need to be multiplying, not adding. Okay? The other thing is that you can't use this rule when you're doing something 2 to the power of 3 to the times 3 to the power of 5. And the reason that is because these base numbers are not the same. So no, because the base of the exponent, and remember when we did exponent rules, we said the base is that big number, is not the same. Okay? So when you're multiplying powers and only multiplying, not adding, not subtracting, right? So be careful, not adding or subtracting. You can add the two exponents together. So say I have, you can, so when multiplying powers, powers or terms, right? So you can add the exponents together and keep the same base. Cool? And that's your answer. So I'm just going to go in and write these as a single power. So when I'm asking you to write something as a single power, right, and this is on your test, do not evaluate. So don't give me the answer. Just give me like something to the power of. So it's going to be written as you're going to be writing it as base, right, and then exponent. So that'll be kind of how you write it, and I'll show you what that means. So here, if I'm asking for the single power, I'm just going to say, okay, 6 to the power of 18, right, multiplied by 6 to the power of 3. So I'm going to do 6 to the power of 18 plus 3 because they both have the same base. So I can just add the exponents together. So I'm going to do 6, 18 plus 3, 6 to the power of 21. And I'm not actually going to go plug into my calculator what 6 to the power of 21 is. I'm just going to leave it as that. Okay, same idea here. You have 3.1, same base. So we know they're multiplying, so we can add the exponents. We're going to do 6 plus 9, right? 3.1. 6 plus 9 is going to give us 15. So we have 3.1 to the power of 15. And again, I'm not going to plug that into my calculator and solve it. I'm going to leave it as is. Same here. So try doing C and D on your own and then come back and watch the video's answers, okay? So try them on your own. Just pause this video here and then come back and try taking them up with us. Okay? So then here again, I have the same base. I have a -5 and a -5, so I'm going to leave it. I'm going to say, okay, it's multiplied by, which means I can add the exponents. So I'm going to do 8 plus 14. -5. 8 plus 14 is 22, so it's going to be -5 to the power of 22. And again, I'm not going to go in and change and calculate that because I want it as a single power. Same thing here. I have 12, 12, and 12. It's the same base. I know that this 12 is secretly to the power of 1 because when something is to the power of 1, it's just the same. Right? So I'm going to do 10 plus 6 plus 1. right? And I'm just going to do the math. So 12, 10 plus 6 is 16, plus 1 is 17. It's important to remember that this is a 1. Otherwise, your answer changes. Okay. Okay, I'm just going to move on. So now, if we're dividing powers, right? Let's complete the following table. So I took 10 to the 7 and I put them in. So I put in 7 tens. 1, 2, 3, 4, 5, 6, 7. 7 tens. And then it's divided by 1, 2, 3 tenths at the bottom. Now, when you have something like this, you can actually start crossing out the tens at the top. Right? Now, all the ones at the bottom are done. So I'm just left with 1 down here. And I'm left with how many up here? 1, 2, 3, 4. So I have 10 to the power of 4. Okay, because that's how many I'm left over with. And it's just over 1 because I had canceled all the ones at the bottom. So let's try doing this again. So you have 10 to the power of 5. So let's do that. 1, 2, 3, 4, 5. All over 10 to the power of 2, which is just 2 tens. So let's go cancel stuff out. We can cancel these ones out. And cancel another one out here. And I'm left over with these 3 right here. So I know I have 10 to the power of 1, 2, 3, 3. Okay? And just continue to do that for the rest of them. So I did 5, 5, 5, 5. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, all over 1, 2, 3, 4, 5, 6. Right, so let's just cancel out 1, 2, 3. So it's 3, 4, 5, 6, and I'm left over with 3. So I know it's 5 to the power of 3. Next one, 2 to the power of 5. So we're just going to put that in. 1, 2, 3, 4, 5. All over just 1, 2. Cancel these out, and I'm left over with 4. So 2 to the power of 4. And then last but not least, I have negative 3 times negative 3 times negative 3 times negative 3, right? Because it's 3 to the power of 4. Negative 3 to the power of 4. Then I have negative 3, negative 3, negative 3. I'm just going to go cancel. 1, cancel these out, and I'm only left over with 1. So I have negative 3 to the power of 1, or just leave it because you don't need to write to the power of 1. Right, so what patterns do you see in this table? So if you look at this, negative 10, 7 divided by 10 to the power of 3 is left with 10 to the power of 4. 10 to the power of 5 divided by 10 to the power of 2 is left with 10 to the power of 3. 5 to the power of 9 divided by 5 to the power of 6 is left with 3, right? So you're starting to notice that you can just minus the powers, right? So what patterns did you see? So I wrote you can minus the exponents. That was one thing that I saw. So state a rule for dividing two powers of the same number. So I'm going to write, if you have the same base, you can subtract the numerator or the denominator from the numerator. So numerator and denominator. And make sure you take it so that you're doing 6 minus 3 and not 3 minus 6. So always take the numerator first. So it's going to be numerator, right, minus denominator, not the other way around. So an example of this could be if you have 2 to the power of 6 divided by 2 to the power of 4. If I rewrite this as 2 over 6 divided by 2 over 4, I know that I can just subtract the numerator, which is 2 to the power of 6, minus 4, which is in the denominator, so I'm left with 2 to the power of 2. And if I wanted to leave it as a single power, I'd just leave it like that. Right? So rules for dividing fraction or dividing powers. Change to a fraction, right? 2, for numbers or bases that are the same, do exponents of numerator minus exponent of denominator. Okay. So let's just try writing these as a single power. So a single power just means that you're writing it as base exponent. So don't solve, you're just writing it as base exponent. Alright, so I'm just going to go in here. So first things first, I'm going to just change this into 618 divided by 6 to the power of 3. Right, and I'm going to say, okay, 618 minus 3. 18 minus 3 is going to give me 15. So I know it's 6 to the power of 15. Same thing here. I have 4, 7, numerator, denominator. 7 minus 3, so it's going to be 4. 7 minus 3 is 4, so 4 to the power of 4. And I'm just going to leave it like this because I asked for it in a single power. So try doing C and D and then just come back and make sure you're doing them correctly. So pause your video, come back. Okay, welcome back. So we have negative 4 over 2. Negative 4 to the power of 8 over negative 4 to the power of 2. So I'm going to do negative 4 in a bracket because that's my base, and then I'm going to take the exponents and just subtract them. So negative 4, 8 minus 2 is 6. So it's negative 4 to the power of 6. Again, same thing here. You have 8 as your base. You have 17. There's an invisible 1 here, so it's going to be 17 minus 1, 8. 17 minus 1 is 16. And if you want, you could draw out 17 eighths, and then you could show me with the 1, and you can cross things out. But this is the rule. Okay? Alrighty then. So let's go on to investigation 3, which is power of a power. So say I have something like 10 to the power of 2, and then I put a bracket around that and I say everything to the power of 3. What I'm basically saying is I'm going to add 10 to the power of 2 times 10 to the power of 2 times 10 to the power of 2, which if I break it down even further is going to be 10 times 10 times 10 times 10 times 10 times 10, right? Or 10, because these are multiplying by each other, or it's going to be 10, 2 plus 2 plus 2. Because they're the same base, I can just add the exponents together. So it would be 10 to the power of 1, 2, 3, 4, 5, 6. 10 to the power of 6. Right? So let's try to do this for our next one. So I have 10 to the power of 4 times 10 to the power of 4. Now I know they're both multiplying by each other, so I know I can just leave the base as 10 and then add the exponents together. So I have 4 plus 4. 4 plus 4, yeah. So then I have 10. 4 plus 4 is going to give me 8. Okay. Let's try 5 to the power of 6 times 5 to the power of 6, and it's 3, so I have to do it 3 times. 5 to the power of 6, which is the same thing as saying 5. 6 plus 6 plus 6. Right, so I have 5. 6 plus 6 plus 6 is 18. So then I have 5 to the power of 18. Right, and then I have 2 to the power of 5. Everything to the power of 4, so I'm going to take 2 to the power of 5 and multiply it by itself 4 times. 2 to the power of 5. And because I'm multiplying, I can just add the 5s all together. Plus 5 plus 5 plus 5 to the power of 20. Okay. Same idea here. So we have negative 3 to the power of 3 times negative 3 to the power of 3 times negative 3 to the power of 3 times negative 3 to the power of 3. So I have all the same base, so I can leave it the same, right? And then I can just add the exponents together. So it's 3 plus 3 plus 3 plus 3, right? So that's negative 3 to the power of 4. Notice how each of these, the amount of times you add these powers is the same as the power of the power, right? So what you could say, a pattern that you see, is when the bases are the same, you can multiply and it's to a power. You can multiply the two powers together, right? So that's just going to be a rule. I'm not going to bother rewriting it. But so if I have 2 to the power of 8 all to the power of 2, I can just do 2, 8 times 2, which will give me 2 to the power of 16. Because it's the same thing as writing out 2 to the power of 8 times 2 to the power of 8 equals 2. 8 plus 8 equals 2 to the power of 16. I will get the same number. So you can skip all of that and just do it that way, instead of having to write it all out. So we can use that same rule to write 16 to the power of 9 with a base of 2, right? So let's break up 16, right, so that it has a base of 2. So let's look at 16 and say, all right, if I multiply 4 by 4, right, I will get 16. If I multiply 2 by 2, I'll get 4, right? So if I break this down and I say, all right, so it's 16 to the power of 9, right? So let's write it as 4 squared, right, to the power of 9, because that's the same thing as saying 16 to the power of 9. But I want to write this as a base of 2. So I'm going to go one step further. I'm going to break that 4 apart too. I'm going to say, okay, 2 to the power of 2 to the power of 2 to the power of 9. Right? So now I have 2 to the power of 2 to the power of 9. So how can I write this as a base of 2? I can say 2 to the power of 2 is the same thing as writing 2 to the power of 4 to the power of 9, right? And I can go further and I'm going to say, okay, 2 to the power of 4 multiplied by 9, 2, 4 times 9 is going to give me, I believe, 36. So 2 to the power of 36 is the same thing as saying 16 to the power of 9. And if you go into your calculator and you actually do that math, do 2 to the power of 36, you get 6.87 to the power of 10 to the power of 10. And then let's do 16 to the power of 9. You get the exact same number. So you know that these two are equal to each other. So that's how you can use this rule. And this will become increasingly important in grade 11 when you take exponential functions, because you will be able to do this. And it's really important for that class especially. Okay? Alrighty. So let's do a rule for power of powers. When you have a number or same base with same base with a power to a power, you can multiply the two powers together. And that's important. Okay? And this is only when you have a power to a power. Remember, when you're multiplying powers, you can only add them together. So let's write these as a single power. So we have 16 to the power of 18, all to the power of 3. So I'm going to, 6 to the power of 18, all to the power of 3. So I'm going to say it's a power to a power. So I'm going to do 18 times 3. Right? So it's 18 times 3 because it would have been 18 plus 18 plus 18, which is going to give me 6 to the power of 54. And don't bother evaluating this because I want it as a single power. Okay? Same thing with 2 to the power, 2.36 to the power of 9. So 2.3 is the same base, and then we're just going to multiply the powers together. So we have 6 times 9, right, which is going to give us 54 as well. So try doing the next one by yourself. Hopefully you have an understanding for how to do this now, right? Pause this video, come back, and rewatch it. All right, welcome back. So we're going to do negative 5. We have 8 to the power of 7. So we're going to do 8 times 7, which is going to be negative 5. 8 times 7 is 56. So it's going to be negative 5 to the power of 56. That's going to be my answer. So this one says, write each of the following with the base indicated. So we want 8 to the power of 5, right, with the base of 2. So let's break down 8 into its little, into a little bit of a way for me to solve this. So I know 4 times 2, right, gives me 8. I can break down the 4 into further of 2 and 2. So now I know if I do 2 times 2 times 2, I will get 8, right? So I can go in and I'm going to say, all right, 2 to the power of 3, because you take 3 2's, right, will give me 8. So I'm going to substitute the 2 to the power of 3 equals 8. So I'm going to sub this in for the 8. So I'm going to say, all right. So I'm just going to write that here. Sub 2 to the power of 3 for 8. Right, so I'm going to put that in. And when you're subbing, you always put it in brackets. 2 to the power of 3, everything to the power of 5. Right, equals 8 to the power of 5. You don't have to do it this way if you don't want to. But so we can say 3 times 5. 2 to the power of 15 is equal to 8 times 5. And you can check this by just plugging those both into your calculator, and you should get the same answer. So let's do 2 to the power of 15. Gives me 32,768. And then if we do 8 to the power of 5, it also gives me 32,768. So they're both equal to each other. Right? So try doing B by yourself. 64 to the power of 4, or with the base of 4. So we want to change the 64 into some exponent of 4. 4 to the power of what will give you 64? Okay, so try doing it by yourself. Pause this video. All right, welcome back. So how I like to do this personally is I like to just break things down. So I know 64 is 8 times 8. So I know 8 squared is 64, right? Then I'm just going to break the 8 up even more to a 4 and a 4. 4, 4, 4, and 4. So I know if I did 4 times 4 times 4 times 4, I'd get not 64, right? So let's just do this. 4 times 4 gives me 16 times 4 will give me 64, right? So I just like to go through it like that, try to break it down to as much as I can. So I say 4 times 4 is going to give me 16, times 4 is going to give me 32, right? So 4 times 4 is going to give me 16, times 4 is going to give me 64, right? So I know that if I do 4 times 4 times 4, it's going to give me 64. So I know 4 to the power of 3 is equal to 64. So now I'm going to go plug in or sub 4 to the power of 3 for 64. Let's go do that. So let's do 64 to the power of 7 equals 4 over 3, which is 64, to the power of 7. And then let's just multiply. So I have 64 to the power of 7 equals 4, and that's a power to power, so I'm going to do 3 times 7. So 64 times 7 to the power of 7 equals 4 to the power of 21. And now if you go back in and you find 64 to the power of 7, it's going to give you this huge number. It's going to be like 4.39 times 10 to the power of 12. And if you do the same thing for 4 to the power of 21, you'll get the same number. So you know that they're equal, and that's a good way to check your work. Okay, and that is it. That's the end of our lesson. I'm going to take up lesson 6 with you, 6B, and yeah,